Hello students, welcome all. So we are going to discuss today the continuation of the previous class. You remember we have covered um, some expansions, binomial, expansions, binomial formulas, all that. So let us today discuss little bit more about expansion formulas which are used in JEE as well as NEEV. So first we will write down all the important formulas and then I will explain a few of them, right, using the same Taylor series. Let us write down expansion formulas. Expansion expansion formulas. First, e power x. Let us write e power x. 1 plus x plus x squared by factorial 2 plus x cube by factorial 3 plus x4 by factorial 4 and so on. This is the expansion of e power x. Sin x last class I discussed, but let me write again. Sin x is x minus x cube. Odd factor will be coming here. Remember, and alternatively sign will be changing, right? Minus x7 by 7 factorial and so on. Next, let us write cos x. Cos x expansion is 1 minus x square by factorial 2. Here all the even powers will be coming, right? Plus, and alternatively sign is also changing, x4 by factorial 4 minus x6 by factorial 6 and so on, right? Next, tan x. Tan x also let us write tan x. Tan x can be written as x plus x cube by 3 plus 2x5 by 15 plus 17x7 by 315 and so on. Next, cot x 1 by x minus x by 3 plus minus x cube by 45 minus 2x power 5 by 945 and so on. All minus terms are coming, but of course these things we are not using, but I am writing for the sake of record. You may note that secant x, cosecant x, all these things are there. Secant x is 1 plus x square by 2 plus 5x power 4 by 24 plus 61x power 6 by 720 and so on. Cosecant x is 1 by x plus x by 6 plus 7 x cubed by 360 plus 31 x power 5 by 15120. Oh, so big numbers are coming. Then next, I will also highlight what are the things we have to remember. Ln 1 plus x we must remember because questions will come. X minus x squared by 2 plus x cubed by 3 minus x4 by 4 plus x5 by 5. It will continue like this, right? And of course here remember there is a condition here that magnitude of x must be less than 1, then only we are using this. Then ninth, log base a also we can say. If log base a comes, then 1 plus x. I think we can convert them in terms of base e, right? So we can take log base 1 plus x by log and then a we can write. So this side I am just not writing it because this can be definitely done. In log base A we can convert using log. Okay, base change rule we can apply. So let us go for something different. 1 plus x power n already we discussed previously, right? So that is 1 plus nx plus n minus 1 by factorial 2 x square plus n minus 1 n minus 2 by factorial 3 by x cube plus dot dot dot. So in all this, we are taking this condition that mod of x is much lesser than 1. Very small, not just small, very small. We can take this is small only, but for approximation purpose, um, we take it further. Because if x is very small, we can neglect higher powers of x. That's the idea. Then other things we can expand, but no need. If you want, you can write it 10th 1 by 1 minus x can be written as 1 plus x plus x square plus x cube plus x4 dot 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 dot. Here also we are taking this mod of x is less than 1. These conditions we are applying. Everywhere we will apply this condition, and then we can do all kind of calculations here. Right? And if you take 1 plus x in denominator, 1 by 1 plus x is there. So we can bring minus 1 in the numerator and we can expand them, right? So we can write it as 1 minus x plus x square minus x cube plus x4. Alternatively, you have to keep on changing this sum, right? So other things we can do as it is. But these are the form. But let me give you the Taylor series because all this can be derived from Taylor series. What is the fundamental behind is Taylor series about x is equal to 0. X equal to 0 if you write, so f of x can be written as f of 0 plus x into f dash 0 plus x minus um, sorry x square f double dash 0 plus x cube f triple dash 0, like that it will go. I think last class we have derived it for sin x. Suppose if I consider fx as sin x, then what is sin 0? So substitute. What is f of 0? F of 0 is 0. What is f dash 0? First you differentiate f dash, that becomes sin x become cos x. Cos x you put x0 1. F double dash 0. Sin x differentiation cos x. Cos x differentiation minus sin x. So anyway this will become 0. What will become f triple dash 0? So sin x differentiation cos x. Cos x differentiation minus sin x. Minus sin x differentiation minus cos x. Then it will become minus 1. So like that it is going to happen, right? And then you can try to substitute the values and find out what will be the values of this. And I think here we have to divide by factorials also. Factorial we need to divide by factorial of this, factorial of 1, factorial of 2, factorial of 3, like that it is, right? Taylor series. So let us try to do this, substitute this and check. So f of x means sin x. I can write this as f of 0 means first of all 0 plus x. Factorial 1 is 1 only. F dash 0 is 1 plus x square. F double dash 0 is 0, so I am not writing. Next, that is going to be minus x cube by factorial 3. That is going to be 1 only, minus 1. Right, so like that you will be seeing that. So you can clearly say that sin x is going to be x minus x cube by factorial 3 plus x5 by factorial 5 and so on, right? This is what is sin x. You can try for cos x also, anything. Let us try for e power x. Let us try e power x. E power x is the function. Okay. So let us differentiate first. F dash x is e power x only. F double dash x is also e power x. F triple dash also is e power x only. Right. So let us try to apply this f of x formula. So f of 0 plus x by factorial 1 um, f dash 0 plus x square by factorial 2. The same, this Taylor series about that we want to expand it. Right, the same thing. F double dash 0 x cube by factorial 3 f triple dash 0 and so on. Try this. So this e power x I can write f0 means I will substitute 0, so it will become 1. X f dash 0 means it is 1 only, so x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 and so on. This will become the expansion of e power x. So like that you can see that we can write all the different type of expansions using this idea. Yes. So e power x or anything can be expanded in the same manner. The function, So I think you don't have to remember. If you remember this idea of Taylor series, then we can solve any, when we can expand any. But remember, whenever we want to expand, we should expand in such a manner that the values or power of x we are expanding, right? That x should be very very less than 1. Why? Because higher powers of a smaller quantity or fraction will become smaller and smaller. So if you assume that x is very very small, then you can neglect these powers, right? So that's the importance of these formulas, expansions. So today we are done with the expansions. We have covered all the kind of expansions and you can now apply it, right, in the problems, right? So that you can do it. Then next what? Next, I think we have covered all the basic maths starting from integration, differentiation, basic calculus, trigonometry, coordinate geometry, algebra. Algebra, I think we have not covered, but there is not much. There is not much in algebra. Algebras, there are not much in. But one basic concept of algebra I will discuss, which are used in some inequalities, wavy curve method. And there might be a few things will be there, quadratic equations and all that, which you know already. So after this, we can start the first chapter of physics, which is nothing but basics of measurements, units, dimensions, and all these things. And a part of this is also the practical physics, which can be also studied, but those things are done in the lab. So for example, the measurement of least count, vernier caliper, screw gauge, basic concept you can discuss as a theory, right? That's not a problem. But in practical physics, when you go in the physics lab, you do that and then you will learn more about it. Okay. So let us discuss basic about algebra before we go further into units and dimensions. So basic algebra. So first thing you should know about direct variation. Variation. Direct variation means one quantity is directly proportional to other. Let us say x and y. We are studying, so y is directly proportional to x. So y is equal to some constant will come, constant multiply x. So the ratio y by x is going to be constant. That is what it means. Okay. So if y is proportional to x, so ratio y by x is proportional. So that means if you change x to x1, sorry, x1 to x2, Let us say you change x1 to x2. Y also changes from y1 to y2. But this ratio y1 by x1 remains same as y2 by x2. Okay, that is called direct variation. So direct variation means if you increase one quantity, it is also increasing, but it is linear increase. We are talking of linear increase. So you can represent them by a straight line also. X y relationship can be represented by a straight line passing through origin, right? Now what about the, and where is application? Lot of applications are there. For example, suppose if you consider volume and temperature relationship, if pressure is constant and mass of gas is constant, so you can assume this kind of relationship that volume by temperature ratio will be constant. This is called Charles law. Charles law. Okay. So in kinetic theory of gases, Charles law is applicable. Volume temperature relationship of a gas, the ideal gas. What about other type of variation? Other is called indirect indirect variation. Indirect variation. So what is indirect variation means? Y is proportional to, inversely proportional to x. Inverse relationship is that. Inverse means again power is one only. Power of x and power of y both are one. Okay, not inverse square it is. So here you can see y is equal to some constant multiplied with 1 by x. So x and y is going to be constant. So this kind of relationship also is also known as rectangular hyperbola. Also note that this xy constant is known as rectangular hyperbola, which we have discussed in coordinate geometry. Xy is equal to constant. Either this way or this way it can go. Okay. So this axis are the asymptotes for this. Not exactly it match, but it appears to be matching. Right. Then what else? So here, what is the applications of that? So PV is equal to constant. Here, if you are keeping temperature constant and mass of the gas is constant, this is called Boyle's law. Boyle's law. Okay, so lot of applications of these quantities are there in physics. Many places you will find them, right? These things are there. Then what else? Done. Anything else? You have arithmetic progression, AP, GP, HP. Also, let us cover that. So arithmetic progression, AP. Arithmetic progression, AP. So it number A plus D, A plus 2D, all this, nth term is A plus n minus 1 into D, like that. So here D is called common difference, right? So what about the sum of n terms? Sum of n terms is first term plus last term. First term plus last term divided by 2. So that becomes A plus um, 2A plus n minus 1 into D divided by, right? Okay. Then what else? What is called arithmetic mean? That also note that. So suppose there are numbers like A1, A2, A3, AN. They may not be arithmetic progression, but arithmetic mean can still be defined as the average value A1, A2, A3 plus AN divided by N. This is called arithmetic mean. Then what about geometric progression? Geometric progression. GP. But in maths, you will be studying in more detail. Geometric progression means there is a common ratio AR square, AR cube, like that, another term will be AR per power n minus 1. Right, so here again they can ask sum of n numbers. So sum of n numbers can be calculated. There is one approach is there. So suppose these are this is the sum, right? A plus AR plus AR square plus AR cube up to n number of terms are there. AR per power n minus 1. I will multiply this with R, then this will become AR, this will become AR square, this will become AR cube, like that, and I will get AR per power n. Okay, so now we'll subtract this. Suppose I subtract it and I'll take as in common, so 1 minus R. I'm going to do subtraction. So you will see this term will get cancelled, this term will get cancelled, this term will get cancelled. So here, before that n minus 2 term was there, right? So we got, I think this all the terms will be getting cancelled, right? Everything will get cancelled. So here first term will remain and last term will remain. Then what do you get? Then you can write this as a 1 minus r power n by 1 minus r. Okay, that's how we can do it. That's the formula for this. Okay, that is the geometric progression. Sum of, and sometimes they give sum of infinite terms. That means n is going to be infinity. So this term is becoming a by 1 minus r if r is less than 1. Okay, note that. This condition we will be using in many calculations. Then what is called GM? Suppose if there are terms like A1, A2, A3, A4, AN, they may not be in geometric progression, but still we can define geometric mean. Geometric mean can be defined. How to define geometric mean? GM. GM is defined as 1 by nth root of the product of these numbers, right? Product of this number 1 by nth root. This is called GM. Similarly, the last thing is about harmonic progression. Harmonic progression. HP. Harmonic progression is nothing but 1 by A, 1 by A plus D, 1 by A plus 2D, 1 by A plus 3D, 1 by A plus n minus 1 into D. So this means this is nothing but arithmetic progression. The reciprocal of these numbers are going to give us arithmetic progression, right? Reciprocal will give. But anyway, here we can do same manner. But what idea is about harmonic mean? Let us note harmonic mean. HM. So we can have any amount of numbers. Let us say A1, A2, A3. They may not be in harmonic progression, but still HM can be defined as HM can be defined. How to define HM? HM is defined as, not directly HM is defined, 1 by HM is defined as average of 1 by A1 plus 1 by A2, like that, plus 1 by AN divided by n. Okay. Now see how HM will be written. Let us write HM. HM will be written as n divided by 1 by A1 plus 1 by A2 plus dot 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 plus 1 by A. Okay. This is how harmonic mean can be defined. Right. So we can define all this. So now there is an important point to note that, note here, that AM is greater than equal to HM, AM is greater than equal to GM is greater than equal to HM. You can try, you can check that. Check. Let us take two numbers and check. Suppose if I take 1 and 2. So arithmetic mean becomes 3 by 2. Right? Geometric mean becomes root under 1 into 2. That means nearly 1.414. Harmonic means become how much? 2 divided by 1 by 1 plus 1 by 2. It will be 4 by 3. Now check. This is 1.5, right? This is 1.414 and this is 1.33. So 1.5 is greater than 1.4 is greater than 1.50. So this law or this idea will be valid every, particularly it's math on this, right? It's math. So now we got this sequence series. Then what else? Sometimes this componendo differendo is also used. Okay, so note that if x by y is equal to a by b, so x plus y by x minus y is equal to a plus b by a minus b. This is called applying componendo and dividendo. Applying componendo and dividendo. Right? So by applying componendo dividendo, we can prove it, but I'm not going into detail of this. This is very easy. Plus 1 you do, then take ratio minus 1, then take, right? Because you can take add 1, right? If I add 1 both sides, nothing will happen. So you'll get x plus y by y and a plus b by b. If I subtract 1, then x by y minus 1 and a by b minus 1. So x minus y by y and a minus b by. Now I can take the ratios of these two and you will be getting this, right? So the idea is that it's not new, but it can save your steps in calculations. Okay, then what else? Most of the things can be done within this. Whatever we have learned basic things about that. What else? Log. Log is okay. Let's write something about log because some of you have studied it, but might be we have not studied about this. Logarithm means what? Logarithm means it is a method. It is a method to express powers. Example. Example. Let us say 2 power 3 is equal to 8. So 3 can be written as log base to 8. So it is a method of expressing the power 3 here like this way. Okay. And this base, which is the base 2 here, this base 2 also comes here. Okay. So let us now write down the properties, some of the properties of log. What are the properties of log? So first property is log. Base may be anything, but let us say that this is log x plus log y. Base can be anything. Let us write base as a. So here what happens? We can say it is x multiplied by y. Same base. Similarly, if I say log base a x minus log base a y, so base remains same and it will become division of x and y. Okay. Then third, log of 1 is 0. Base can be anything because a power 0 is 1, right? Then what else? Base change also rule we should know. So log AB can be written as log B log A. Base can be any value xx. Okay. Note next. um, log b power x can be written as x into x gets multiplied log ab. Similarly, if we have log a power x b, then it becomes 1 by x log ab. In maths, you will be studying in more detail, but I am writing here formula physics because applications will come in physics, right? Now, very important thing to note about what is log base e a written as, it is written as ln a. So ln a, we should remember this is called natural log with base e. Okay, so we should note what is the value of ln2. ln2 is 0.693. If you want, you can remember value of ln3, ln4. 4 ln you don't need, ln5 you can remember. So I'll give the values of this. Now you can write it because in some calculations we have to use this, right? So let us note down the values of this. So if I write ln3, I'll give the value in calculator because it will be used 0.986. But you can use as 1.1 in some calculations. Then what about ln5? It is 1.60943. You can use it as 1.61. Okay, up to that much. Otherwise, in the questions, they will give you the values. And what about the value of each irrational number? Sorry, value of this is 2.718 something continuously. So it's a irrational number. Irrational number. Okay, we should note about that. So what else in algebra that we are supposed to know? Yes, one thing is that also we should know about the sum of first natural number n plus 1 by 2. Sum of n square n plus 1 to n plus 1 by 6. Sum of n cube n plus 1 by 2 the whole square. Remember, for example, suppose if in somewhere application comes, you want to add 1 plus 2 plus 3 plus up to 100 you want to add. So how will you add them? You will use this formula sum of first natural number. So you will use this 100 by 2, 100 plus 1, and then you can solve it. This is 50 into 101, right? So you can solve it 5050. Like this. Similarly, if they are sum of squares, let us say, suppose they say 1 square plus 2 square plus 3 square plus dot 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 plus 100 square. So you will use this 100 plus 1, 2 into 100 plus 1 by 6. So 100 into 101 into 201 by 6. This calculation you can do. Similarly, if they ask this 1 cube plus 2 cube plus 3 cube plus dot 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 plus 100 cube. So you will use that 100 into 100 plus 1 by 2 whole square. So that is going to be 50 into 101 whole square. This calculation can be done. I am leaving it. So that's how we require them in some calculations, right? These are used in calculations of physics, so we must know them. These are maths. If you want to prove them, why it is, you have to go in maths and do that. But not needed. Why to waste time in physics class? Because that's not needed right now. We are supposed to know them and use them. That's all. Then you can solve problem. Basically, you want to solve problem, right? Okay. So these things you can use as a, important, formulas, algebras. You can use them. What else? Anything else is remaining? Algebras. And then Vevical method I will teach because sometimes the idea of inequalities will come. Let us take wavy, wavy curve method. Wavy curve method. What is this method? For example, suppose if I have inequalities, x square minus 6x plus 5 is equal to 0. Hmm. Can I do it? Factors. Definitely. I can write factors, or they will give you, you have to find out less than 0. What are the possible values of x? So I can definitely make equation first. X square minus 6x plus 5 equal to 0. Find the roots. X square minus x minus 5x plus 1 is equal to 0. So x minus 1 minus 5 x minus, sorry, x minus 1 is equal to 0. So x minus 1 x minus 5 is equal to 0. So we have roots 1 or 5. So number line we can represent this 1 and 5. Okay, this first you represent number line. Then how to check this sign? First of all, suppose I take value 0 here, 0 is coming this side. If I substitute here as 0, 0, 5, 5, this expression is coming what? Is it coming negative or positive? That's what it is coming. What? This term is coming positive first of all. In this expression, if I substitute x is equal to 0, it is coming as positive. That means this whole expression is positive. Then this side will be negative. Okay, this side will give negative, and this side will be giving positive. So wavy curve method means we can draw like this way, positive, negative, positive, some way we can. So if you need the values where we want it, so this side we know positives will be coming, this side negative will be coming, and this side positive will be coming. If you want, you may remove this part. This is not required means you can remove that, but this is how negative positive is being decided, right? Negative positive is being decided. How we are deciding that? Because this side is positive, this side is negative, this side is positive. Okay, so suppose they are saying that we want negative value, means we need the values of x between this. So this is the idea, we want this value, so x must be lying between. Of course, if you want it's negative, equality is not there, so don't put equality. So x must be between 1 and 5. That's the answer. Okay, so whenever this wavy curve method comes, first of all take this expression, find out, and then put the number line and check any other values what the sign is coming, then draw the wavy curve. Okay, that's the method used to find out the region of space or range of values we can calculate. Between 1 and 5 means any values, and if they are asking x has to be numbers, let us say x represent the number of human beings, or number of objects, number of bullets, number of objects, then it cannot be fraction. So between 1 and 5 we can go for 2, 3, 4, like that. Okay, so some idea will be there, we can solve it problems. So I think then we are done with this, and the graphical concept already we have discussed, but when we will taking up kinematics again things will be coming. So now we are done with the basic maths, we have completed the basic math. Then we will be going next with units, dimensions, measurement. That will be the next chapter. That will be the beginning of your physics. So congrats, we have completed the basic math, right? And we will be entering into the now the spirit of physics and solving, understanding the concept of physics and going into depth of the problems. Why we have covered this? Now you know something. You cannot be thinking that I don't know anything. Now you know the basic concept of math. Any question is coming, you can think, right? And we will be discussing more details on that, right? So thank you for attention. Then we'll meet in the next class. Bye bye all.